So the next page is solving systems of equations, and these are linear equations this year. Now next year you're going to have different types of equations like maybe quadratic and exponentials and all other shapes, but for solving systems this year they were only linear. So this solution of a systems of equations is where the lines intersect, because you're looking for points that are on both lines, okay? So if the two lines intersect, that one point is on the green line and it's on the orange line, so that's the only point that's a solution to the whole system. If the two lines are parallel, then there is no solution because there's no points on both lines at the same time. If the two lines are on top of each other, then you've got millions and trillions and billions or an infinite number of solutions that are on top that solve both equations at the same time. So that's what's happening. So whenever we're solving a systems of equations, we're looking for where they intersect. So one way to do it is to take your two equations and just graph them on some graph paper and just visually look and see where they intersect and see if you can tell what the intersection is. What's the x, y coordinate, right? What's the point where they intersect? You can find the x number and the y number where they intersect. And that's all fine and great when we had graphing calculators and it was easy to do, or we had the graphing calculator with the nSolve technique, which it was doing the graphing kind of internally and doing that and finding the point where they intersect. So how are we going to do them today when we don't have a graphing calculator? Any ideas? Pause the video and see if you think about it for a few minutes, see if you can come up with anything. Okay, hopefully you pause and you come back. Now, one way we might do it without a graphing calculator is literally we could solve each of these for y equals so that we could graph them easily. Go find the y-intercept, put a point on it, use the slope and go up and over, put some points and connect the lines, right? And then do the same thing for the other one. So on a piece of graph paper, I could hand graph two lines, totally by hand, no graphing calculator, and just go look to see where they intersect. That is one way to do it. That's how we used to do it before there were graphing calculators. Yes, it can be done. It is not too much. Now, there's another way to do it also algebraically, meaning with math without any graphing involved, and that's what I'm going to show you today. All right, they have names for these, and I really don't care about the names, but this is kind of what I call just stack them up and just add them together. So what you do is you get both equations where you have the x's in the same position as the y's and the equal signs in the same position and the number in the same position. So I have x first, y second, equal sign number. It doesn't matter what the order is as long as the second one matches it. So since this was x, y equals number, this one is also x, y equals number. If not, I can always use my, whatever you do to one side, do to the other to rearrange it to make sure that it's in that order. Once they're in that order, what I can do is add the two equations together to make a new equation. The goal when you do this is to hope that either the x's go away or the y's go away, okay? So if I add a negative 4x and a positive 4x, do the x's go away? Yes, that becomes 0x, and 0 times anything is just a big old 0. So here's my 0. And then I have 8 minus 2y. These are like terms, so 6 good guys are going to be left alive. Here's my equal sign. And then if I have negative 12 and negative 24, I have a whole bunch of bad guys, and it's negative 36. So notice what happens is when you do this method, what you want to happen is one of the variables to go away. Now that I only have one variable, I can solve the single equation for that variable, okay? So how do we undo multiplying by 6? We divide by 6. If I do it to one side, I do it to the other side. So y equals a negative 6. So if you visualize on a piece of paper where these two lines are intersecting, the point where they intersect, the y number is a negative 6. I have half of the location of where the two lines intersect. I still need to find what? The x number. So what you do now is you take your information that you know, which is y is negative 6, and plug that y number either in here or in there. I just can use either equation that I want to. So if one equation looks like it's less messy than the other one, use that one. These are both fairly straightforward, so I don't know if one makes a difference over the other, so I'm just going to use the first one. So I'm going to copy down negative 4x minus 2y, but instead of putting the y there, I'm going to put parentheses because I know what the y is. It's a negative 6 equals negative 12. So all I did was copy this equation down in where the y was, made parentheses, and drop my y number in that I know. Now I have an equation that only has x in it, and I can solve for x. So negative 4x, negative times negative is a positive 12, equals negative 12. And of course I want to get x by itself, so I need to get rid of the 4 and the 12, and the 12, the add subtract will always be done first. We're going to undo the add subtract first. So that cancels out, and I'm left with negative 4x equals, let's see, that's negative 24, bad guys and bad guys. Divide by negative 4 to undo multiplying with the x, so divide by negative 4, and x equals positive 6. So this point, 6 comma negative 6, on a coordinate graph, I don't know what the two lines look like necessarily, but if I go over 1, 2, 3, 4, 5, 6, and I go down to negative 6. So over 6, down 6, there's a point right here where the two lines intersect, and that point is my solution to that. If I plug 6 and negative 6 in for up here, if I plug a 6 for the x and a y is negative 6 and do this math, this will be true. If I plug 6 and negative 6 in on this equation, it will also be true. So that is the solution to the systems of equations. That is the x number, that's the y number, okay? So they're not that bad, you just have to stack them up and add them together. So let's go do number 2. Pause the video, give it a whirl. Okay, hopefully you're coming back. Now, I made sure that the x is matched up, the y is matched up, the equal sign's matched up, and I have numbers on the end. And then I look to make sure that one of these is going to disappear. So if I add the 4 and negative 4, will the x's go away? Yes, these just cancel each other out, right? So then I'm left with 10y equals 20 of my good guys killed 20 of these, so minus 10. And then to get y by itself, we would divide by 10, and then we have y equals negative 1. So far, I know where these two lines intersect, the y is a negative 1. And I know that if I plug negative 1 in one of the equations, it will be true with whatever the x number is that we're about to find. So I still need to find the x number. So I take the y number that I know, and I can plug it back into either one of the original equations. So it doesn't really matter, but since 30 is kind of big, I'm thinking I'm going to do the first equation. And again, it doesn't matter which one of the two you use. 4x plus 8 times y, and y is a negative 1, equals 20. So I use the first equation, so don't get started on one equation and switch to the other one. It has to be one equation or the other. And then 8 times negative 1 is a negative 8 equals 20, and I still have my 4x in front of it. So get rid of the 8 first, add 8 to both sides. And then I have 4x equals 28. And then divide by 4, x equals 7. So 7 comma negative 1 is the solution to that systems of equations. If I plug in a 7 for the x and a negative 1 for the y, this will be true. Same thing down here. If x is 7 and y is negative 1, it's true. If I were to go graph the two lines, that's the point where they intersect. That's the point that's on both lines. All right, so let's do the next one. So I'm getting ready to do this one, and I notice, because I'm going to stack them and add them up, the x's are lined up, the y's are lined up, the equal sign, the numbers are all lined up. But I notice that the x's are not going to go away, and the y's are not going to go away. So what do we do now? Good question. What you're going to do is you're going to change one of the equations so that it will go away. So since the 9's are already are the same number, I just need one to be positive, one to be negative. So it doesn't matter which equation I use, but I can multiply one of the equations by negative 1 so that the negative 9 now becomes a positive 9. So I don't want to do it to both equations. I just want to do it to one because I need to have a negative 9 and I need to have a positive 9. So doesn't matter which equation. I'm just going to do the bottom equation just because that's just what I like to do sometimes. So the whole equation is going to get multiplied by negative 1, which means the right side is going to get multiplied by negative 1, and the left side is going to get multiplied by negative 1, which is okay because as long as whatever I do to one side, I do to the other side, I have not changed my equation, right? So the first equation did not change. I'm going to copy it down again. Equals negative 25. The second equation, though, negative 1 times negative 4 is now a positive 4x. Negative 1 times negative 9 is now a positive 9y. Here's my equal sign. And negative 1 times negative 23 is a positive 23. And now when I add them together, the y's are going to cancel out, right? So I still have equals, and 23 of those killed 2 of those, so I got a negative 2. And good guys are going to win, so 2x, divide by 2, x equals a negative 1. So I'm halfway done with finding where the two equations intersect. The x number is a negative 1. So now I need to find the y number, right? That's what I'm missing is the y. So I'm going to take my x number and plug it into either of one of the original equations. Now don't use the one that you changed down here. Go always back to one of the original equations. And I think I'm going to use the first one up there. It just looks interesting. I don't know that it really makes any difference. So negative 2 parentheses minus 9y equals negative 25. And x was a negative 1, so I dropped that in. Negative times negative is a positive 2 minus 9y equals negative 25. Subtract 2 on both sides to get rid of the 2. And that means I have negative 9y equals negative 27. Yeah. And then divide by negative 9 on both sides to undo that multiplication. And x is going to equal a positive 3. Oh, did I do that? Oh, these are y, sorry. That's y is going to equal a positive 3. I think I got carried away with my solving there and started talking about x's instead of y's. So these were all y's all through here. So y is positive 3. So negative 1, 3 is the point on the graph where the two lines intersect. if I plug in x is -1 and y is 3 in both of these equations, they will be true. All right, there's your solution to systems of equations. Go try this one. You're going to need to multiply one of the equations by something so either the x or the y will eliminate. And I'm pretty sure we need to make one of the y's eliminate because they both have a 1 in front of them. So if you're coming back and you're ready to check your answer, now you can multiply either equation by -1 because I had a positive 1y and I got a positive 1y. And I need one to be positive, one to be negative. So it doesn't matter which one you do. Let's just say I did this one this time. So here's my -1. So -1 times -8, or -1 times 8 is now -8x. Negative times positive is now -1y. And negative times negative is now positive 16. Second equation I did not change because I want it to stay positive y. And that equals -5. And now when I add them together, the y's are going to cancel out. And this is going to equal 5 of those get killed, so now I have 11. And this is -11x. Oh, isn't that pretty? It's all just going to come together. -11 divided by -11 means x equals -1. So in my solution, the x we know is a -1. That's half the point of where they intersect. Now I need to find the y. So I'm going to do the y over here. And I'm originally, remember to go back to one of the original equations, and you could use either one. Does not matter. And I don't think I'm going to use the second one. It just seems like it's smaller numbers. So -3 times x plus y equals -5. And of course my x is a -1, so that goes in here. So negative times negative is a positive 3 plus y equals -5. And then I'm going to subtract 3 on both sides to make that go away. And y is going to equal, I don't know why I drew the line down there. That was weird. So -5 minus -3. It's not dividing, it's just -5 minus 3. That's bad guys and bad guys, so that's -8. So this was, what number was this? Number 6? Yes, there it is, my -8. So x is -1, y is -8. So that's the point where they intersect. All right, let's go do number 9 down here. Okay, so when I look at this, are the x's lined up? Are the y's lined up? Equal sign and the numbers on the end? Yes, they are. And then I'm looking to see 5 and 10. Those are not going to cancel. 1 and 7, they're not going to cancel. Okay, so I need to figure out a way to make one of these cancel. So since this one has a -7 and this one has a 1, I'm thinking I could multiply the first equation by a positive 7 because that will make that a positive 7. So you could do that. The other thing you could do is you could make the 5 become a 10 by multiplying the first equation by a -2. So whether you did multiplying by -2 or you did it by multiplying by a positive 7, either way will work in the end if you don't make a mistake along the way. I'm going to multiply by the 7. So 7 times 5 is 35x. 7 times y is plus 7y equals, and 7 times 9 is 63. Second equation I did not change. It's going to stay as is. Minus 7y equals -18. Here we go. And then we're going to add those together. So this becomes my 45x. 7y's cancel out equals, and this actually also becomes a 45. So if you do that math, 63 minus 18, you get 45. So divide by 45 on both sides. X equals 1. So in this intersection where the two lines intersect, x is 1. And x will be my solution when I plug it in for the x is 1. So now I need to go find the y. So either one of the original equations I could plug it into, and then this one just looks like it's smaller numbers, so I'm just going to use it. 5 times x plus y equals 9. And x is 1. So 5 plus y equals 9. I see what it's going to be. Minus 5, y equals 4. So 1 comma 4 is the point where the two lines intersect. All right, number 10. Try this one on your own. Give it a whirl. See what you can figure out. See how you can change one of the equations so that when you add them together, something will disappear. Okay, hopefully you're coming back. You could have multiplied the second equation by a positive 4, and that would make the x's go away, right? Or you could have multiplied the second equation by a 3, a positive 3, and that would make this a -9. Either way will get you there. So I'm just going to go ahead and multiply by a 4. Either way you would do it is fine. So the first equation is going to stay the same. Oops, make that x plus 9y equals 9. 4 times x is a positive 4x. 4 times -3 is -12y's. And 4 times -6 is a -24. There we go. I'm going to draw my line, add these together. The x's go away. I now have a -3y is equal to 9 from 24. I think that's 15. And it's a -15 because bad guys won. So divide by -3, divide by -3, y equals +5. So in my intersection of this one, y is a +5. All I need to do now is go back and find the x number. So back to one of the original equations, and this one looks like it's got smaller numbers in it. So this is x minus 3 times my y, which is 5, equals -6. So now I'm solving for x. So x minus 15 equals -6. All I did was that math right there. Add 15 to both sides. And I think that gives me x equals a +9. Yep, because 9 plus 6 is 15, so there it is, x equals 9. So in my intersection, x is 9 and y is 5. Those are the two numbers that will solve my systems of equations. All right, last one down here. Give it a whirl, pause your video, come back and check and see how you did. Okay, hopefully you're coming back. Now 7 and 2, there wasn't an easy way to get them together. You could have done 14, but that means you had to multiply this equation by a 2, and you had to multiply this equation by a -7 because you need them to be opposite signs too. So the easier way was maybe multiplying this first equation by a -3, and that makes the y's be opposite signs but the same number. So I'm going to multiply this one by a -3. So -3 times -7 is a +21x. -3 times y is -3y equals, and then 3 times 19 wound up being 57, and that's a +57. There we go. Second equation I did not have to change because I wanted it to stay +3y, so they would cancel out. And this is -19, and I'm going to draw my line. If it'll draw, I may have to hold it and move it. There we go. So the y's cancel out on this one, and I have 19x is equal to, what was this one when I did this one? 38. And then you divide by 19. Surprisingly, 38 divided by 19, x is 2. So x is 2. I'm going to put this over here. Here's my 2. I just need to find the y number. So we're going to take the x number and put it back in one of the original equations. And they both, oh, but y doesn't have anything in front of this one, so I'm going to do that one. -7 times my x plus y equals -19. And then 2 is this thing. And so 2 times 7 is -14 plus y equals -19. I'm going to add 14 to both sides. And that means if I can draw the line across the paper and it's moving, y is going to equal, let's see, bad guys are going to win, that's -5, isn't it? Yeah, so there's my -5. Where's my answer? Here it is. So 2 comma -5 is where those two lines intersect. So that is one way to do it algebraically. Now there's another method we're going to do tomorrow, but this one, they call this method elimination because when you add them together, one of the variables eliminates or goes away, cancels out. So anyway, that's the method that we've been doing today. We're going to learn a different method tomorrow. Bye, guys.